Airflow, Big Data Ninja, that's me. There's a lot of ways this lecture could go. I mean, I tried to make this topic as general as possible with some technical deep dives, with indexes to other blogs, and some use cases. So it's kind of a mix and a match of everything, low level, high level. It's going to be a bit confusing, but the idea is to give you some sort of an index that for everything related to Airflow, why you need it, what is it, different architectures, example, getting started, and stuff like that. So feel free to interrupt, ask questions. It's supposed to be more like a discussion. Okay, and naturally all the content, links, examples are uploaded as well. So a small disclaimer, I'm not the best, even though I may sound like I'm arrogant. It's a personal issue with me. It's only because I like what I do very much. And it's a lot of enthusiasm, nothing more special than that. So feel free to challenge me, say you're wrong. I think otherwise it's okay. It's just sharing with you my experience, my personal philosophy about how to do big data. And you can send me comments to my private email. I like to talk about data, so here we go. A little bit about me. As we said, certified skydiver, third-degree black belt. I started this meetup 2 years ago. Started with the AWS content and then moved along to other subjects. We have about 2,500 people in our community. I work with several startups and small, medium businesses, publishers like Voila, investing. Scream is a nice startup about GPU database. Very interesting if you have big data and you want to do analytics. This is my consulting company. I do consulting, if you like. Jaja is a nice startup that did voice over IP about a decade ago. Something like Skype, only on cell phones. Cool thing. So about the meetup, we have 3 meetups: AWS, Big Data Demystified, and BI and Analytics. We had 2 successful events there. It was founded 6 months ago. Also nice if you're interested. So let's start. A long time ago, everything was simple. About 20 years ago, 3-tier architecture. We had a web server, an API, database, data warehouse, and yalla balagan, you have an application. Then came big data, and everything exploded and became much more difficult. Then came the cloud that made everything twice as hard. And then came your invoice. Just as an example, this is the AWS big data stack. They don't publish it or market it this way. I specifically do this because I want to show you that even in the AWS ecosystem that everything looks nice, there's a huge stack of technologies you need to understand and to know what to use or what not to use or when to use what. Just for example, in investing.com, a different stack on GCP. A lot of technologies related to data, to marketing. It's a big mess. So the idea behind this meetup is just simply share knowledge, help you getting started, architecture, best practices, and whatever I did in terms of experience, I'm sharing it with you. Take it or leave it. The problem about the big data ecosystem is it keeps growing. Every couple of years, there's a shuffling of everything. For example, today's topic was exploding in the last 5 years. It became very popular. Now everybody's talking about it. Not sure why they're talking about it, but they definitely think they need to learn why. So my solution basically is usually to start with the cloud, if you're getting started, apply your big data there, and then apply some data engineering methodologies, and it should be okay. but it requires a lot of understanding in terms of cloud, big data, architecture, DevOps, some coding. So it's a challenge. So basically, this meetup is all about this challenge and helping you getting started. The agenda for today. We're going to talk about the architecture of Airflow. Apparently, there are a lot of ways you can install Airflow. And some of the basics and some of the use cases. And we'll take it from there. Okay, I got a small demo prepared. Okay, so let's talk about the architecture. 6 ways, different ways to install Airflows from sequentials, locals, Celery, Mesos, Dusk, and GCP Composer. We're going to talk briefly about each of them, just to get the audience, to get to know the audience. Has anyone tried to play with Airflow? Raise your hand. Okay, almost nobody. Okay, so I'll brief to the more advanced examples and start with the basics one, and we'll take it from there. So the simple, straightforward way to install Airflow would be this architecture. You have a web server, SQLite database over here, a scheduler and a sequential executor, and some directory which has all your dogs inside. This mode is usually good when you're getting started. It's very cheap, very simple. You can only process one task at a time. There's no parallelism, which is a good thing and a bad thing. Let's talk about this again in the next installment. I wrote a manual over here how to install it. It's a simple technical copy-paste thingy. Not much to do here. It's all naturally on Linux. Some commands to get started, but nothing to go deep. So let's talk about this one. This is more interesting from my perspective. I use it in most of the projects where the scale is not massive, simply because of operational simplicity. The idea is to take, instead of the SQLite, to take a RDBMS, say MySQL, put it behind, and then configure Airflow to work in local executor mode. That means you can have multiple schedulers and work in parallel on tasks. It's good if you have a lot of jobs, say 50, 60 per day, per hour. So it's very easy to scale vertically. That means you take the same instance and you just add more cores if you have a problem, instead of maintaining a full cluster. One of the benefits, besides the parallelism, is that you have all your backend data stored in MySQL, say, so you can access that directly for analytics purposes. I will talk about this soon. One second, just I'll finish the sentence. So I also did a nice manual on how I installed this. If you're interested, relatively straightforward.
What do you mean by multiple schedulers? I mean, I played around with it, and as far as I know, it's like a limitation of it that you can only have one scheduler.
Log into the machine, right top enter, and you'll see several services.
Okay,
That's it. Nothing too complicated. Forget the architecture. The key thing with the local executor to remember, you can run in parallel. Okay? Forget the architecture. It's not very interesting in this specific use case. Okay? But that's a good question, relatively speaking. Celery executor. If you want to scale vertically, that means you are a very large company with a very large data set. One server for Airflow is not going to cut it, simply because you have failures, and you have peak times, and you have things you need to run in parallel, and it's not going to be 1 or 2 or 3 tasks, it's going to be 1,000 tasks. So you need some sort of architecture which is scalable horizontally, meaning you can add more servers as you need. I personally did not use this cluster because most of my use cases can be accommodated by the previous installation, but say all the big players with data, PayPal, if they're using Airflow, probably Airbnb, which is related, they probably have a huge cluster like this. But again, only try this cluster and this architecture after you pass through the previous ones. The installation is simple, get the pros and the cons quickly. And this is a headache, operational headache. You don't want to do that unless there's an actual need for that. So as we discussed, you can do scale on the horizontal level. There's an additional component called Flower to monitor all the tasks, the health of the worker, and you have some queues and pulls. I didn't go too deep into that because I didn't use it, and I really like to talk only the things I touched and work with. But there's a lot of experience out there on blogs, especially on this architecture and its advantages. So if you're interested, talk to me.
Can you take one step back and explain the use cases you would use Airflow?
Yes, there's a specific slide for use cases. We'll talk about it and I'll show examples. But basically, the question was about, for the video, I'm repeating your question. The question was, when would I use Airflow? What's the use cases? So I'll cover it soon. If I haven't answered it, stop me and I'll try again. Another architecture, if you're using GCP cloud, something very easy to get started. It's called GCP Composer. It's a managed service by Google. All you have to do in terms of maintenance is press a button and you have a cluster, horizontally scalable. The problem with this architecture, this managed service, is that the architecture is a bit different than the open source. This is your project, and the database, the backend database, is hidden. In order to approach that database, you have to go through a Cloud SQL proxy, which is doable, and it's very nicely explained, but kind of limits you. And when you want to add some custom packages, it's kind of like this. So again, I started out with this, but then I moved to a do-it-yourself cluster. It took me about a week to get the handle of it. So it's nice to get started with a managed service, but you pay a lot more. You pay like $400 a month, $300 as a bare minimum, $400 if you want some more parallelism. And right now we are using the local executor, this one, and we're paying about $70 a month, so it's meaningful in terms of cost. So basics. So why Airflow? The first thing you want to know about Airflow, just let me check the sound, please. Good. Airflow is open source. It's vendor agnostic. Despite the fact that GCP has a managed service of Airflow, it's free, it's open source, and it has a large community supporting it, meaning it has a lot of connectors. You can install many third-party components and expand your abilities for ETL rapidly. The idea behind Airflow is basically orchestrate your data pipeline. Orchestration, meaning what? In data, most of your problems are getting the data from a source to destination. even if you're working with a data lake methodology where you ingest the data, put it in your storage layer, and the rest of the layers, the modeling, the transformation, take the data from there, still you need to some sort of responsible adult that will manage the timing of everything. The jobs, the ETLs, getting the data, deleting the data, doing some transformation, doing some modeling. So Airflow is an orchestrator, basically, and it has a lot of cool features to allow you to do complex stuff, like graph dependencies. I'll show you in a second, but the idea is that this job is dependent on this job, and this job is dependent on these two, and so on and so forth. You can create some complex graph dependencies. It can handle failures quickly and with logic. You can do reporting and alerting, which is a nice feature, and you can do monitoring and enforce an SLA that this task must end in 1 hour, for example. And it's scalable, and it's based on Python, which coincides with the ecosystem of big data. Almost everything in big data, every major technology that succeeded is based on Python. It's used by Python, so it kind of connects well with the rest of the ecosystem, regardless of which cloud and technology. Yes, please?
So if you compare it to, for example, the old school programs like Control-M, UC4, and others.
I'm not familiar. The question was to compare it with Control-M.
Yeah, there are old schedulers that called Control-M or UC4, and there are many more.
There are many schedulers,
Yeah,
yes.
tons, but what is the basic pro or advantage of Airflow over the others?
I don't see something very major about Airflow compared with the rest.
Well, it's free, I guess.
It's free, but the learning curve is hard. Believe me, I broke a few teeth working with it.
Sure.
And I have quite a few. But it's open source. It's vastly adopted everywhere. Every cloud vendor somehow recommends using Airflow. Almost the entire industry somehow landed on Airflow. Everything else kind of fades out. There's no really good reason for that from my perspective. It's a good tool, but no more.
Sure, but which kind of enterprises use it, or?
Everybody?
Everybody? Like Airbnb and most.
Is there a company behind it now that kind of maintains it and sells support and all that?
Yes. I can share with you the name, but there are companies who sell a complete solution with support and everything. Any more questions? Basically, if we touch upon this point, what's the strongest advantage of Airflow? It's the community. That's it. That everything you want to connect to orchestrate is already plugged in. If you want to connect to a database, you just choose the component, hope to God it's going to work, but if it works, it works. Okay? The rest is giving you a lot of functionality that every ETL tool will give you. And it's code-based. That's it. There's no really good reason to choose Airflow, and that's it. There's a lot of good orchestrators in the cloud. In fact, about 3 years ago when I was working in Walla, I had the pleasure of time to examine my architecture, so I did a benchmark. And at the time, I tested Uzi from a Hadoop ecosystem. I tested Azkaban, which is a weird orchestration tool. And there's Luigi, also quite popular at the time. Most of them did the same. You have some sort of graph dependencies if you have complex jobs. You have API access, you have GUI access, and you have code access. So basically everything you need to generate a pipeline and to have some sort of visibility of what happened and why and when.
I see that you guys are using Talent.
Yes, we're using Talent. Yes. For the legacy ETLs.
How would you compare Airflow to Talent? Pros and cons to each.
Pros and cons, talent versus Airflow. Oh. Well, first of all, talent has two basic solutions. One community, one enterprise with payment. The community is fairly simple to get started. Everything is drag and drop. There's a nice GUI. In Airflow, there's a nice GUI, but you can only see the status. It's only visibility. You cannot edit your job there. So
You have to go and code.
you have to open your IDE for Python and start giving the מקלדת and yalla balagan. In talent, it's quite easy if you are not code-oriented, if you're an analyst, if you're a BI person. But if you're a data engineer, it's a non-issue to work with Airflow, and kind of makes sense. So basically, we use both simply because talent holds all the legacy ETLs, and it makes no sense to start an Airflow cluster here in the data center and replace all the ETLs. Just generated a new cluster of Airflow in the cloud and started all the new ETLs there. That's it. They're completely decoupled, not related. It's not a bad solution. It's just different. Demo. So coming all this way and not seeing how an Airflow cluster looks like is kind of a big no-no. So this is an Airflow cluster. This is how it looks. It comes with a lot of examples. If you install the open source solution, it comes with a lot of examples which are relatively self-explanatory. I use this for development purposes. There's a lot of options here. Key features here are seeing what ran and when. You can see the DAG ID and the task, the subtask, and you have here, over here, some logs. If you want to understand what happened exactly, really light reading before you go to bed or when you wake up in the morning. Let's take a simple example for Athena. Athena is a database by AWS, SQL, syntax Presto, directly over S3. Say I want to know what's this job. I didn't write this. So I press code, and this is how it looks like. Okay? So I know it automatically by looking at the end of the document that the task run query runs, and then the task drop query runs, and then the task transform query. So I have a basic understanding of what's the job all about. And I can start from the top. Simple imports, if you know code, by Python. Simple definitions of scheduling interval. No scheduling, but usually you can put here hourly, daily, every day, specific date, and so on. You can even put cron-like expression, if you know Linux administration. So you have an operator for, this is where the DAG begins. You have an operator for everything, basically. For Athena, you have an operator called AWS Athena Operator. And instead of installing JDBC and writing all the custom configuration, all you have to do is put the operator, give it a name, write your query, and just give the input that the operator requires. For example, where to write output. And that's it. It runs, assuming you have network and security applied. Same goes for drop. Drop table if. And transformation, it's a simple CTAS, create a table as select. Nothing too fancy. So how would one know how to get started? Well, I did a lot of effort of indexing that for people. So if you go to my website, in the blog section, and you write Airflow, you have everything I've written on Airflow in the last year, and that's quite a few. a lot of examples here and problems. You can start with this one. Its link is attached. It kind of explains all the process and index other blogs. Reason to start using Airflow, reasons to use do-it-yourself cluster, by examples, okay? Another blog, only on example with a specific lecture with examples. For example, running a query on BigQuery and saving the results into a new table. Fully explained example, relatively simple, and some more examples. The reason I don't go terribly deep into it because every company has a different pipeline, different technology stack, but essentially, if you're using Airflow, before you start, take your technology stack, take the Airflow documentation, and find a match in terms of operators. Let's do that for a second. Give me a name of a technology for data in your company. Just shout something.
Spark.
Spark. What company?
Windward.
Wind what?
Windward.
Windwork. Okay. That's
Windward.
Wind.
Neighbors from upstairs.
Sorry, I'm not with my hearing device, so I can't hear you well. Upstairs. That I heard. So everything related to Sparks. You have a lot of things. Okay, Spark SQL or Spark O?
SQL.
Spark SQL operator. As simple as that. All you have to do is import that Python, run your SQL, tell him where to connect, how many executor calls, how many executor memories, and yalla balagan. As simple as that. Just make sure your APIs are up. That's it. Another example, MySQL. Okay, let's try MySQL. MySQL to GCS, vertical to MySQL, and so on and so forth. So basically, you write Airflow in Google, Airflow docs in Google, first link, and you get started from there. Before you install, before you play. If it doesn't have your connector, stop, don't get any further. Or consult with someone who did something with Airflow. So, questions before I proceed?
I guess you can write you can expand it, right?
You can write your own Python, you can expand it, yes, the community is full.
Write your own connectors if you want.
Write your own connectors, write your own everything. The entire code is on Git, so תתפרע, לבריאות. I attached some screenshots. Oh, this one is good. Let's see it on live cluster. There's a graph view. This is a simple graph. Let's say branching, branching, branching. Branch operator. Let's try this one. And a graph view. Boom. You start here, you branch, you run in parallel, only works in specific executor, remember? Not the first one, the easy one. The more advanced one, the local executor, runs in parallel. Naturally, you have to assume you have enough cores in your machine, and then it joins together and finishes.
Can it schedule on different nodes, like in a cluster?
Schedule on different nodes?
Like branch and have, like, if you've got like 4 nodes, and
You
you want
are-
the job to be scheduled on those 4 nodes in parallel.
Probably, I didn't check, but usually you don't take care of it. You just let it run. If it runs, okay. If not, chaval. There's cool stuff here like Gantt, which is meaningless here, but maybe we see it here. No, that's task duration. This is why I prepare slides for everything, but for that I forgot.
It shows you like the scheduling?
Sorry?
It shows you the scheduling?
It shows you the scheduling. You see what ran when and the duration. So you can examine your work and see if there's a bottleneck. There's naturally some basic details. You can trigger it to run now. I won't do that. And that's more or less it. So we covered everything for the demo. Oh, notice this part. Took me a while to notice, but one, this column is very important. Schedule basically says what's the schedule of the job. Last run, and these links, they are shortcuts. For example, this one is run. So kind of helps. Okay, so we covered just one last comment before we go on. If you are in the process of upgrading, starting a new cluster, back up your dogs and your variables here in admin. Admin, you have configuration, oops, connections. Just back up what you need and variables. Okay, if you added some custom key values, just bear that in mind if you play with this. So use cases. Basically, every basic ETL you have in the company should work, will work, assuming it's not a too bizarre database. You should have a operator for it, and everything should be easily transferable to there. Some cool examples. We have a Slack integration. I did a POC for that. Again, totally written by example, what package, what I did, how I did. And the idea is to get a success or failure in your Slack. If a specific job is important and you want it to be notified when it fails, you can do that. This is the most interesting use case we are using, and this is partly the reason why we switched to do-it-yourself cluster. As you remember at the beginning, I told you that the second option entails installing a MySQL database. So we installed that, so we'll have a direct access to the database, and we'll pull data from there to BigQuery to do some analytics. We're a data company, data department, and the idea was to get a report in the morning without entering the cluster in the email on the way to work. Svebgia, this is the list of your failures where you need to handle carefully. The idea was, you don't see it, but there are days here, and you see that everything yesterday worked, but 3 days ago, there were a lot of failures. Another use case we did, we, together with the logs from BigQuery, where there's a user, query, and cost, we did a graph and a dashboard that says cost per day. And we grouped that by project, so we'll know each DUG how much it cost us. Because as we discussed in big data, it's very easy to do costly mistakes. And apparently we are still doing costly mistakes. Despite my experience, despite everything, cost is still high, and there's always room to reduce that. So we need some sort of nice monitoring that will say, 24 hours delay, what changed and why. So the idea behind this, how we did this, bit not related, but Airflow has an option called XCOM, X communication, cross communication. The idea is that from the DUG, you inject key values to the MySQL, and from there take it to anywhere you like and do the analytics. So what we did is we combined that and some federated queries. That means we ran BigQuery on top of the Airflow database. seamlessly without an ETL. We got the data. And from there to the dashboard, it's relatively straightforward. We took the logs of the cost per query as well, and we created the dashboard. And that's the use case we used here in investing.com. Questions? Summary. Why Airflow again? I usually like to say that a lot because the market has spoken. It took me a while to adopt Airflow. I only adopted that 2 years ago, although I heard about it 5 years ago. It's a good orchestration, and it has a minimal cost. It has a lot of extensions you can use. You can customize it, and you can do a good match between your use case, your business use case, and the technology. So if I have to summarize it, Airflow is flexible enough to do what you need, very fast, very cheap, and very simple after the learning curve period. So to conclude, wrap it up, a good architecture is all about being cheap, being simple. So this is why I chose Airflow in the end after experimenting with several tools. Call to action, please register to our meetup groups. If you're interested in AWS pipelines, lecture 1 to 4 in the YouTube. Please subscribe if you enjoyed the content, and keep in touch. All the relevant links are here. Questions?
Yeah.
Yes?
Thank you. So the process itself is being done well. If I query, let's say, S3 file system using Athena.
Yes.
So the process itself of querying is being done there, or does it take the data and use the Airflow code and stuff like that?
The question was about the process. If I'm using Athena and the file system, where's the data stored of Airflow?
Where the process is being done.
Where's the process is being done?
Yeah. Let's say I group the data. I
Select, and you want to group the data?
I would like to group the data.
Basically like any other ETL tool. Say Talent, for example. What's your poison? What's your favorite tool? The one you're using?
Talent, we have an extra.
Talent. So you take Talent and you approach Athena. You write some sort of workflow, a pipeline. It connects to Athena, selects the data. It goes all the way to your server. You do what you want, and you send it to where you want. You can leave it on your server. You can send it back to Athena. You can send it to a different destination. It's an orchestrator. It does not decide anything. You decide.
The data to its service. That's what it's.
In theory, yes, it goes through to the servers.
So would you recommend using it on-premises databases, like traditional databases?
Yeah, well, if I recommend to use it with traditional databases on-site, yes, but keep in mind that it takes some sort of learning curve, and maintenance of Airflow is non-trivial to get started with. So if I remind you what I did in investing, no change. We left the Talent on the data center. Only on the cloud, we choose Airflow. Okay, and again, gradually, we started with the platform as a service. It was too expensive, but by then, we learned Airflow inside out. So we threw away that, spent 2-3 days on do-it-yourself cluster, and the knowledge was already there, so the transition was relatively trivial. But after you know the pros and cons of Airflow. So if you're in, so recommendation, if you're in GCP, start with the Composer solution, pay the extra buck. It will be worth your time. You can start in 1 hour, the first ETL. Yes, please.
AWS has Airflow?
To my knowledge, AWS does not have a platform as a service Airflow, but they highly recommend this in their white papers in the website.
What about installing Airflow on Kubernetes?
Airflow on Kubernetes. What's your scale? If it's a huge scale,
Medium.
what's medium?
A few dozens of gigabytes a day.
Don't bother. You overcomplicate things, it's over-engineering. Airflow by itself is goddamn complex. So why throw another complex technology
So what
in
do you
mix?
recommend? Just install it.
Do it yourself on a machine, take a database in the background. It will cost you what, $40, $50 a month? Why bother optimizing that? I mean, if you have the time and you have the luxury and your entire stack is containerized, do it. But as a rule of thumb, simplicity in engineering is the king.
When you install it on separate EC2 machines, you need to monitor it, you need to do everything
Yes.
that Kubernetes or other
Yes.
orchestration tools gives you
Yes,
out
you
of the
do.
box. So it's
But
It's a
it's, again, it's trade-off, yes. It is choose your poison. If you're comfortable in containers, do it. But from my perspective, again, my perspective is big data only. I don't do production OLTP, traditional workloads. I don't do that. So I hardly use containers in my stack. But if you're comfortable there and you're like this with containers, do it. Okay? Any more questions before we wrap up? Please.
Any recommendation regarding running Airflow in a highly available manner?
Yes.
Approach,
If you are highly scalable, if you have intensive workload, do it highly available. But if you have, say, 60,
not the intensity, but it's rather the jobs need to run every few minutes, so you don't want to have a downtime for more than a few minutes.
Availability.
Yeah. The availability is
we don't do it. We just invest a lot of time in the monitoring on top of what happened, what not happened, why. We are investing a lot of time right now in data QA. So I would focus my energy there. But it's really a matter of how important is it for you. From my perspective, it was a waste of time.
Omid,
Yes, please.
do you have an on-premise solution for that?
Sorry?
On-premise.
On-premise, what about it?
The Airflow. Can you install it on-premise or in a domain environment?
Yes. Yeah. The do-it-yourself manual I wrote should work if you use Ubuntu 18, version 18. Okay? Shouldn't be a problem. Okay, thank you very much.